Ever wondered how we define motion? What does it mean when we say something is moving? Well, motion is simply a change in an object's position relative to its surroundings over a period of time. Throughout this discussion, we'll dive into various terms that help us understand this concept better. Distance, displacement, speed, velocity, uniform velocity, acceleration, uniform acceleration, retardation, and uniformly accelerated motion. Remember, understanding motion is the first step to understanding the world around us. Starting with the basics. What is distance and how does it differ from displacement? Let's break it down. Distance refers to the total path covered by an object. It's like tracking every step you take on a hike. On the other hand, displacement is a bit different. It's the shortest distance from your start to end point, and unlike distance, it has both magnitude and direction. So the distance you walk from your house to the park and back is different from the displacement, which in this case, would be 0. Now, how do we measure how fast something is moving? Well, speed is the distance an object covers in a given amount of time. Picture this, if you drive a car for an hour and cover 60 miles, your speed is 60 miles per hour. Simple, right? But speed only tells us how fast we're going, not the direction. Now let's talk about velocity. This is where direction comes into the picture. Velocity is the displacement or change in position per unit time, and it always includes a direction. So if you drive 60 miles to the north in an hour, your velocity is 60 miles per hour north. But what about uniform velocity? This is when an object moves at a constant speed in a specific direction. It's like driving on a straight road at a steady speed. No speeding up, no slowing down, just a smooth ride. So while speed is just how fast you're going, velocity tells us how fast and in which direction. What happens when the speed or velocity of an object changes? Well, that's where the concept of acceleration comes into play. Acceleration is defined as the rate at which velocity changes over time. It's about how quickly an object can change its speed or direction. This could mean an object is speeding up, slowing down, or changing direction. Then we have uniform acceleration. Just like the name suggests, it's all about consistency. An object experiences uniform acceleration when it changes its velocity at a constant rate. Imagine a car steadily increasing its speed on a straight road. That's uniform acceleration. Now what about when an object slows down? We call that retardation or negative acceleration. It's simply acceleration in the opposite direction. Picture this. You're driving and suddenly see a red traffic light ahead. You hit the brakes to slow down. That's you experiencing retardation or negative acceleration. So, if you hit the brakes on your car, you're experiencing retardation or negative acceleration. How can we describe uniformly accelerated motion mathematically? Let's delve into the 3 equations of uniformly accelerated motion. First, we have the equation of motion that relates velocity, acceleration, and time. Final velocity equals initial velocity plus acceleration times time. This equation describes how fast an object will be moving after a certain period if it's accelerating at a steady rate. Next, we have the equation of motion that connects displacement, initial velocity, time, and acceleration. Displacement equals initial velocity times time plus half the acceleration times the square of time. This equation gives us the distance an object will cover under constant acceleration. Finally, we have the equation of motion that links displacement, initial and final velocity, and acceleration. Displacement equals half the sum of initial and final velocity times time. This equation offers a way to calculate the distance traveled without knowing the time. These equations help us predict how an object will move under constant acceleration. How can we visualize motion? And what happens when an object falls under gravity? Well, motion graphs provide a clear picture of how an object moves. There are mainly 2 types, distance time and velocity time graphs. The former illustrates how far an object has traveled over a given time, while the latter shows how an object's velocity changes over time. Now let's talk about motion under gravity. It's actually a special case of uniformly accelerated motion. You see, when an object falls freely towards the Earth, it accelerates at a constant rate due to gravity. This acceleration is approximately 9.8 meters per second squared. And here's the interesting part. This rule applies to all objects regardless of their mass. So, whether it's a feather or a bowling ball, if we neglect air resistance, they fall at the same rate. So, whether it's a ball being thrown up or an apple falling from a tree, they all follow the laws of motion under gravity. Let's quickly recap what we've learned today. We dove into the world of motion, exploring concepts like distance, displacement, speed, velocity, and their uniform counterparts. We also dissected acceleration, uniform acceleration, and retardation. Then we derived the three equations of uniformly accelerated motion. To visualize these concepts, we examined various motion graphs. Lastly, we looked at the fascinating phenomenon of motion under gravity. The next time you see something moving, remember there's a whole lot of physics happening.